Welcome. In this video lecture, we will discuss how we can solve multi-item or multi-product economic order quantity model under certain constraint. So we will discuss in this lecture, one is with respect to the budget constraint, another one is with respect to the space constraint, and then we will also talk about if we have the multiple constraints. Okay. So let's first of all discuss how can I solve the multi-item economic order quantity model with budget constraint using Excel's option goal seek. And the second we will discuss how we can solve it using Excel solver. Okay. So let's first of all see using the goal seek. So for that, I am considering this particular example. So in which we are saying that we want to find out the economic order quantity for the three products, product A, B, and C. The data the given is that is the annual demand for product A, product B, and product C is given. The order cost is given. The unit cost is also given. So it is also telling us the inventory carrying rate per annum, which is the basically you can say the interest rate, okay, which is 25%. And the budget is that is we do not spend on more than $10,000 on the average inventory of these three products, right? Okay, so as we know that, first of all, what we are going to do is whenever we are going to solve the multi-item economic order quantity model under any specified constraint, we will relax this constraint and we can solve that model with respect to normal EOQ, or you can say the single item EOQ model, which is the economic order quantity formula is 2 into C naught, which is the order cost, multiplied by the demand divided by the carrying cost. So this I is basically the carrying rate, multiplied by C is basically the unit cost. Okay. So if we multiply by I, which is 0.25, multiply by the unit cost, we will get the carrying cost, right? And the after the solution we can also see that if we have the budget constraint, the optimum order quantity formula is that is basically this one. So for the theory, if you want to understand the theory, you can watch the previous video lecture on this, so in which I have explained how we can find out this q, okay, when we have the budget constraint, as well as if we have a space constraint, how we can find out the optimal q, right? So over here, if you can see that we already have the order cost, we already have the demand, we have the CJ, and we would like to find out Q. That is the optimum order quantity. But the problem is this lambda. So what is this lambda? Basically, that is called as a Lagrangian multiplier. And we can find out the value of the lambda with the help of goal seek approach in Excel. So for that, what we are going to do is, first of all, we are going to enter the data in Excel. So this is the data we have entered. So this is basically three products. So the annual demand is given, the ordering cost is given, unit cost is given, and carrying rate is given. Okay, that is this one. This is the carrying rate, right? Okay, then first of all, we are going to apply the single item economic order quantity formula, okay, which is basically this one. So what was the formula? That is basically we are saying that over here is round off because we want to find out the economic order quantity up to 0 decimal place. That's why 0. And then we are saying that square root then 2 multiplied by C naught into D, okay, which is basically 30 into 1000, okay, that is C4 into C3. And then we are saying I into C, that is a unit cost, which is basically we are finding the carrying cost, which is 0.25 multiplied by 50. Okay, so same is the case for product B, right? And same is the case for product C, right? And then we are going to calculate basically the total budget required. So as you can see that how we can find out the total budget, that is a unit cost multiplied by the order quantity of that product. So against that we can find out, so this 69 multiplied by the unit cost, which is 50, so that is this one, which is C10, that is this 69 multiplied by this 50, that is the total budget required for product A, similarly for product B, okay, similarly for product C. Okay, because in our constraint we need to find out the average inventory cost. Okay, because the budget is the average inventory. So that's why what we are going to do is we will sum up this one and take the average divided by 2. Okay, so this is divided by 2. Okay, based on this particular formula, right? So we have calculated this one. And then we are mentioning the restriction, that is the budget constraint is 10,000, which was given in that data set, that it shouldn't be more than 10,000. So as we can see that if we are going to give the order, we are not considering the budget constraint, we simply calculating the economic order quantity for product A separately, product B separately, and C. And when we are calculating the budget, it is saying that the budget we needed is 11,125, but we have 10,000. We want to spend 10,000. So this shouldn't be more than 10,000. So that means we are going to now apply this particular formula. Okay. However, we would be able to find out that quantity. Against that, we should have the total average inventory investment must be less than or equal to the 10,000. So for that, over here we are applying the formula of this one, in which it is saying that we are taking the square root and then 2 multiply by again order cost multiply by the annual demand. Then we have the Cj, okay, that is this unit cost, into I plus lambda. Okay, so what is I? I is basically the carrying rate, or you can say I is interest rate, plus the value of the lambda. This value we need to find out. Okay, so initially let's say we do not have this value. Okay, so over here we have to apply this particular formula. So same formula is going to be applied for product B, the same formula is going to be applied for product C, but the data obviously is going to be changed, okay, as per this one. And the total budget is what we are going to do is, now this is the order quantity, okay, as per the formula. So this multiply by, okay, and this should be multiplied by with the unit cost, okay, that is this one. So this multiply by this plus this multiply by this plus this multiply by this and divided by 2. So over here we are calculating the total budget cost. So the idea is, now we need to find out what should be the value of the lambda. Okay, so that means we need to find out this lambda. However, we would be able to find out the such optimum order quantity that it shouldn't be more than our budget. So how you can do that? So in order to find out the lambda, we can use the Excel. So in Excel, we have the data tab. In the data tab, we have the what if analysis, and the option is goal seek. So if we click over here, this goal seek, so we have the three options. One is a set cell. So in a set cell, we are going to write down the total budget. Okay. So that this must be equal to the two value, this target value. So how much budget? So the budget constraint was, it should be 10,000. Okay. By changing cell mean what value you would like to find out, which mean what is the decision variable, that is actually basic the we want to find out the value of the lambda. Okay, so if we press OK, so over here with the help of goal seek, as you can see that we would be able to find out the lambda, and the total budget is almost 10,000, which is equal to this one. So instead of giving the order equal to this one, we should be give the order of product A 62 point this, product B, and product C. Okay, so if you can see that now it's a fractional, but you can round off like over here. Okay, so you can just simply apply the formula of round. Okay, and then we can say that should be comma 0. Okay, and then we will get the round of value. Same is over here, you can apply same is over here, and then you will see the values. Okay, but right now if you can see that the optimum order quantity having this restriction that the budget shouldn't be more than 10,000. So this is the one way to solve it. Okay, So another way is that we can simply solve this non-linear programming problem. Okay, what was that one? That we would like to minimize this total cost, which is basically the ordering cost against all the products plus the carrying cost, average carrying cost against all the products. So we would like to minimize this total cost subject to this budget constraint, that the average cost must be less than or equal to this budget. So now we can use the Excel solver in order to solve this problem. So how you can do that? Simply, if I am going to do that, is basically first of all we need the data as we need it over here. So first, what I am going to do is I am going to find out the carrying cost. So how you can find out the carrying cost against product A, B, and C? Simply carrying rate, which is the interest rate, multiplied by the unit cost. Simply carrying rate multiplied by the unit cost. Okay, and same over here. So after applying this formula, I would be able to get the carrying cost. And my decision variables are, we would like to find out how much quantity we should order of product A, B, and C. So these are the decision variables. So you can remove this one. Okay. So we would like to find out these values. So let's say initially I am just supposing that this is equal to 1. Okay. So actually we would like to find out these values of these three variables. Okay, so for that I needed what I needed, basically the ordering cost, okay, as well as the average carrying cost. So first of all, I'm going to find out the average inventory, which is Q by 2 for all the product. Okay, so for that I have considered the term that is the average inventory of product A, average inventory of product B, and average inventory order size of product C. So how you can do that? Simply equal. So this divided by 2. Okay, similarly, this is going to be this divided by 2. This is going to be this divided by 2. Okay, and then we are going to find out the this term dj over qj, which is basically the number of orders for product A. How we can do that? Equal the annual demand, which is 10,000, sorry, 1,000 divided by this quantity, okay, which is qa. Similarly, for product B, this is going to be equal to this 1500 divided by this 1. Same is the case for C. Okay. So once we have calculated the average inventory, we have calculated the number of orders. Now we can write down the carrying cost against A, B, and C. So which is equal to this one, for B equal to this one, for C equal to this one. And the ordering cost for product A is given, that is this one, for B is this one, and for C is equal to this one. Now, in order to find out the total cost, what we can do is simply equal some product, and all these must be multiplied and summed with this one. So actually what is going to do this particular formula is, so this is going to multiply by 12.5 into this zero point 0.5 plus 25 multiply by this multiply by this zero point 0.5 plus 30 multiply by 1000 plus 35 multiply by this plus 50 multiply by this. Okay, so we would be able to get the total cost. And the budget constraint is, that is we are going to first of all writing down the simply the unit cost against product A. So this is 50, this is 100, this is equal to 150. Okay, in order to find out the average amount we are spending on this one, this is going to be equal sum product. So this should be multiplied by this uh, this one, which is basically, and this should be multiplied by this average inventory. Okay, qa by 2, which is zero point 0.5, this is this one. Okay, so that is this one, basically that is we are saying that this part. Okay, so we have equal sum product, this is equal to cj, this is cj, this is cj, this is for unit cost of A, B, and C. So we are saying sum product, this should be multiplied by with this one, this is the average. Okay, this is the left hand side, and it should be less than or equal to what is B, and what is the B should be 10,000, that was given in the problem. Okay, which was this one, 10,000. Okay, so once we have entered this one, we have applied these formulas. Now we are going to use the Excel solver to solve the problem. So we will click on the solver. Okay, then what we are going to do is first of all set the objective. that we would like to minimize this total cost. Okay, so this is minimization by changing cell mean. What would be the decision variables? So these cells are the decision variables. So we have three decision variables, and we are going to add the constraint. And that constraint is because over here we are calculating this left hand side. Okay, that is basically this one. So this left hand side is basically in this cell, because what we are doing, we are multiplying this with this. Okay, so which is unit cost multiplied by the average inventory must be less than or equal to what? This should be must be less than or equal to this 10,000. Okay, and press OK, and then make sure unconstrained and this non-linear, because right now we are solving the non-linear programming problem. So if I solve it, press OK. So now you can see that we are getting the quantity, and our left hand side is equal to the right hand side. Okay, so this constraint is satisfied. So we are getting the same answer as we are have got the in goal seek problem. Okay, same. Okay, so it's up to you. Either you can use goal seek problem, either you can use the Excel solver approach in order to solve this problem. Now let's see another example in which we are basically solving this particular problem. Okay, let me this one. This is actually the multi-item EOQ with space constraint problem. Okay, so over here, if you can see that what would be our a non-linear programming model, that is going to be this one. So we would again like to minimize the total cost subject to we have a space constraint, that is the space required for every product. This is the average inventory level we have, and this is the total space we have. Okay, now we are going to apply this one. So first of all, again with respect to goal seek, and then we will solve with respect to Excel solver. So first of all, if I would like to solve it with respect to goal seek, so first of all, we will relax the this space constraint, and we are going to solve the problem with the help of simple EOQ formula. That was this one. Okay, and then we will calculate the economic order quantity with respect to the space constraint, and for that we have this formula. Okay, so again we need to find out the value of the lambda. So how you can do that? Again, first of all, in order to solve this particular problem, that is this one. So product S, X and product Y. So we have written down this entire data set over here. Okay. So again, first of all, we have relaxed the space constraint. Okay. And we have applied the simple EOQ formula. Okay. Like we have done in the budget problem, budget constraint problem. Same is the case for the Y, and then we are calculating the total space required. Okay, that is basically according to the this one, which was this one. So total space we needed, which is basically we are simply multiplying that product X required 50 square 50 cubic feet, and Y is required this one. So based on this, we are simply multiplying this one multiplied by this 50, and this 125 multiplied by this, we will get this one. Okay, because we need to find out the average, which is divided by 2. Okay, so that's why we are doing sum of this one and divided by 2, we are getting this one. So it is saying that if you are going to ignore that space constraint, and you are going to order this economic order quantity of product X, and this is for product Y, so the total space required would be 57,562.5 cubic feet. Actually, the total space we have available, which is 40,000, that was given in the problem. Okay, that is this one. So this is the space we have available. So that means we are going to find the formula of EOQ with the space constraint, and for that we have the formula of QJ, that is equal to this one. So that means we are going to apply this particular formula. But again, the problem is what would be the value of lambda, and this lambda we are going to find out with the help of goal seek approach. So first of all, we have applied this formula. Okay, so let me remove this one. So we need to find out this lambda value. Okay, and what would be the value of x? Again, we have applied this particular formula. Okay, so which is basically 2 into this c naught into d, and this is basically we have applied this one I into cj. Okay, so 0.25 multiplied by this 100, which is unit cost, plus we have this portion which is equal to lambda into sj. So what is the lambda? That is basically e 15, and then sj is this 50. Okay, for x, right? So we have applied for x as well as for y. We need to find out the value of the lambda. And this is basically the total space required. And what was that basically? That is basically the average space required. Okay, that is basically this one. As you can see, that is average space required. Okay, so how you can do that? Simply this quantity multiplied by this cube. Okay, similarly plus this quantity, okay, which is this one, multiplied by the space required, that is this one. Okay, and then divided by 2, because we would like to find out the average space required. Okay, because this is the space we have available, right? Okay, right now we would like to find out the value of the lambda. So again, how we can do that? Simply what if analysis, goal seek. So set cell mean this total space we would like, it should be not more than, it should be exactly equal to 40,000, and the value of lambda we would like to find. Now you can see that these values are going to be changed. Okay, so we got the optimum value. So it is saying that you should use this lambda in order to find out the exact order quantity, and the total space required would be the 40,000. So instead of ordering product X is 490, it should be 410 or 411. This should be not 725, but it should be 475 or 476 if you have this available space. So similar way we can find out with the help of Excel solver. That is the same like we have done in the budget constraint. Okay, so I hope you can do that with the help of this solver. That is exactly the same as we have done in the budget constraint. Now let me solve this particular problem, which is basically the multi-constraint. So over here, as you can see that one constraint we have, that is the average inventory should not be exceed than 16,000. That is a budget constraint, and then the space constraint we have. Okay, so what we are going, and this is the data. So in this part, first of all, we have written down this entire data set. Okay, that is again, I'm going to use the Excel solver. Okay, so the rest of the thing is the same like we have done in the Excel solver for the budget constraint. Again, we are going to find out the carrying cost. So how we can do that? Simply the carrying rate multiplied by the unit cost. So similarly, carrying rate multiplied by the unit cost. So we have calculated the carrying cost for every particular product for strawberry, mango, and pineapple. So these values we would like to find out. Similarly, we are finding the average inventory of all three products. How we can do that? Simply this divided by 2. So again, I am using this value 1 1 initially. Okay, and then we are finding the number of orders. So how we can do that? Simply for strawberry, the demand is 200 divided by this quantity. This is the number of orders we have to place for strawberry. This is the number of order for mango. This is the pineapple. Similarly, demand divided by q. Okay, so this is the average inventories for against product. This is number of orders. Again, we are finding what would be the unit carrying cost. Okay, so carrying cost per unit, so this would be equal to this one as we have find out earlier. So this is equal to this one, this is equal to carrying cost, this is equal to carrying cost, and ordering cost, it is given this is equal to this one, this is equal to this one, and this is equal to this one. Okay, now we are finding the total cost, which is basically equal sum product, these multiply by equal to these. Okay, that is basically the total cost we are finding. Okay, with the help of equal sum product. Again, now we are going to find out these values. Basically, let me highlight this one. Okay, so we have given the budget constraint. So unit cost against strawberry, mango, and pineapple. So unit cost is basically this 6.3, which is basically not the unit cost, but the carrying cost, which is basically 6.3. This is 6. This is 19.5. Okay, and then the space required, that is equal to this one. Okay, so in order to find out the basically the left hand side, which means the total budget required is going to be equal to this multiplied by the basically these values, which is basically equal to this one. Okay, that is basically our this particular constraint. Let me show you again the budget constraint. That is this one. Okay, the left hand side. Similarly, for the space constraint, we are saying that this must be less than or equal to the average. Okay, again, we are multiplying with this one, right? So we want that these should be less than or equal to this one, right? That the total budget must be less than or equal to 1600 and the total space must be less than or equal to 60 cubic, okay, feet, right? So how you can do that? Again, go to the data Excel solver once we have applied these formulas. Okay, first of all, the objective is we would like to minimize this total cost. Okay, minimize. So minimize by changing shall mean these variables we would like to find out, and now we are going to add the constraint. Okay, so this is the budget constraint must be less than or equal to this value, and then we can click add the second constraint. This must be less than or equal to this one. So if we press OK, so we have the two constraints. But there is another way that you can add these two constraints in one go. How you can do that? Simply this should be less than or equal to these two. Okay, so Excel solver will automatically identify that this value should be less than or equal to this, and this value should be less than or equal to this. So this is a check mark. This is non-linear because we are solving the non-linear programming. If I click solve, press OK, now you can see that how much quantity we should order for strawberry, a mango, and the pineapple. Okay, and as you can see that these constraints are also satisfied. But let me apply another restriction that the answer of these quantities must be in an integer form, okay, instead of fraction. So for that we can add another constraint that these must be equal to the integer. Okay, so this must be equal to integer. So press OK and again solve. Okay, now you can get these the actual values. Okay, more realistic one. Okay, so I hope you got the idea. Okay, so thank you so much. See you in the next video.